Okay, everybody, we'll go ahead and get started with this lecture real quick. What we're going to do here is we are going to get started with this note. This is the note that yesterday's note, which would be the 23rd, that lecture ended abruptly, and we didn't have time to have this note taken down. So we're going to go ahead and have you take this note down. Go ahead and pause the video. Write this down under the partition of Poland back in chapter number 13. And then we are going to get started with finishing up where we were in part 1. Okay, you should have all this written down. We're going to go on to where we were previously. Now, okay, this is where we left off with the last video we did. We were talking about astronomy, and we talked about Nicholas Copernicus. We talked about how he questioned Ptolemy's Earth-centered or geocentric model for the Earth, meaning the Earth was centered of the universe. He proposed a sun-centered model of the universe, which is known as the heliocentric model, and that's going to be important. You'll need to know that. You should already have this written down, so we're going to move on here. After Nicholas Copernicus, we've got a guy by the name of Johann Kepler. Now, Johann Kepler was very, very important. Remember when I talked about how these ages do not exist in a vacuum? They always build on top of each other. Johann Kepler is a prime example of that. We talked about the Renaissance being built upon top of by the Reformation, and then now we're in the Age of Reason. It was the thinking of the Renaissance that eventually gave rise to the Reformation age, and Kepler is a product of the Reformation age. Because you look here, who was Johannes Kepler? He was a Lutheran. A Lutheran individual is a product of the Reformation. If without the Reformation, you do not have Johannes Kepler. He's probably still a Catholic. And the Catholic Church did not leave way for any scientific discovery. The Catholic Church was bent on making sure that the status quo stayed the status quo, and they were not going to let anybody come in and change the status quo. So Johann Kepler comes around, and Kepler, he added to Copernicus's theory of a sun-centered universe. And then he went a bit further. See, Copernicus thought that the sun was the center of the universe, which was right. But Copernicus thought that the orbits around the sun were circular. Kepler comes up, and he makes the discovery, or at least the theory, at the very least, a theory that, no, the orbit cannot be circular. They are indeed oval-shaped. But he was coming to the table with this theory. And Kepler was a devout Lutheran, a God-fearing man, one that trusted the Bible above all. And he wanted to make a statement. He wanted to make a statement for all of time that he wanted God to lead him. He does not want to come to the table with a theory and then try to confirm his theory just because that's what he wanted to become known for. He came to the table with a theory, but he wanted God to confirm it, or he wanted God to reject it. Kepler prayed the following prayer as he got started. He said, I ask God to make my spirit strong, so that I direct my glance at the pure truth, from whichever side it should be presented. And I do not let myself be misled, as so often happens today, by the admiration or contempt of person or sides. And by the way, that's the way we need to approach the Bible. We need to approach the Bible, and we need to say, okay, here's what I think about the Bible. I'm going to look to try to have the Bible confirm my belief. No, you need to come to the Bible and say, Lord, direct me. Show me what it is I'm supposed to see. And Lord, if it's something I don't want to see, that's okay, because I want to follow you. But I want you to lead me, Lord Jesus. I don't want to be led by myself. Just like David said, you lead me by the still waters. When we're in our study, guess who leads us? The Holy Spirit, the great interpreter of the Bible. So that's what we need to approach the Bible with, as Kepler approached the science of the age. Now, the next guy is Galileo. Why does my names both sound the same? Galilei. Now, Galileo comes to the forefront of everyone's mind when they think of Renaissance astronomers. He is known for his astronomy. Now, he perfected the telescope. He confirmed the heliocentric theory that Copernicus had already established. And then he agreed with Kepler's theory that the orbits were actually elliptical or oval shaped and not circular. But he also discovered the practicality of measuring time with a pendulum. If you have a grandfather clock in your house, then you have Galileo Galilei to thank for that. Galileo Galilei, he was laying down on his back in the middle of the Pisa Cathedral one day, and he began to notice something. He observed a lamp swinging from the ceiling, and as he watched, he wondered if there was a regular rhythm to that swing. And so he began to experiment with these pendulums, and he found that even though he increased the size of the arc, the pendulum still swung in rhythm. Galileo therefore suggested that one may use a pendulum to keep time. And that's what you have if you have a grandfather clock. You have a device that keeps a pendulum always swinging, and it keeps the ticking of the clock. We have Galileo to thank for that. Now, moving on. The next guy on our list is a guy by the name of Isaac Newton. Isaac Newton, he is almost always well known for his belief in the laws of gravity. He was the first to kind of come up with this. Now, legend has it that Newton was sitting under a tree one day when an apple fell from the tree, hit him on the head, and then he began to question whether or not there was an invisible force that held human beings to the ground. And once he tried over and over again to confirm his theory, he began to write down his findings in his book known Principia. Now, it's important to notice that the laws of gravity have much more implications than just why do we as human beings stick to the Earth. Because planets are kept in orbit based off of gravity. So at that time, they may not have understood the far-reaching effects of gravity, but we see today that, man, this invisible force called gravity, not only does it keep us stationary on the Earth, it also keeps the planets in alignment. And we see that the Earth is truly held to nothing except for that gravity. The Bible talks about God having held the earth on nothing. That's what we see with gravity. It's a great, amazing thing we see. Now, after Newton, we are moving into the field of medicine. Now, this guy you see in the picture here, it's interesting. If you're like me, you saw him and you didn't notice what he was holding on to. Take a look at that picture. What makes that concerning to you? Probably what makes you concerned is the fact that the guy's holding an exposed human arm, and all you can see is the muscular system of that body. Well, this guy's name is Andreas Vesalius. And what he did is he has provided us with a knowledge of the human anatomy by dissecting human corpses. So he got permission to take these dead bodies after they had already died, so he wasn't performing experiments on living participants. But then he would work on trying to pull back the skin and begin to take notes on the inside of the human body. And he began to write a book called On the Fabric of the Human Body. And in this, he has recorded all of the observations about the actual structure of the human body. This guy wrote Grey's Anatomy before Grey's Anatomy was a thing. And no, I'm not talking about the TV show. I'm talking about the book Grey's Anatomy that doctors and medical examiners use to kind of feel their way through the human body. So that's what this guy contributed to the grand scheme of things. Next, you've got another guy here. This guy who looks like he's had one too many donuts. His name is Paracelsus. Paracelsus. Paracelsus, he made the first clinical study of diseases and established the use of chemicals in treating diseases. If you've had a liquid medicine, then you have Paracelsus to thank for that. Next, go ahead and pause this if you want to take this note, but we're going to move on. The next slide we're going to talk about is a guy by the name of Harvey. No, not that Harvey. No, not that Harvey either. Come on, Mac, give me the right one. Here we go. This is the Harvey I'm looking for. Okay, this guy, his name is William Harvey. William Harvey is known as the father of experimental biology. What he did was he came up with the theory that was proven true that the heart alone acts as a pump that pushes blood through arteries and veins in the human body. See, up till this point in history, what everybody presumed that the heart, that the body produced blood, and that the blood was good until a point, and then the blood went bad. And when the blood went bad, it made you sick. George Washington, the first president of the United States, was killed because his doctors thought that he had bad blood and began to cut his arms and let blood bleed out. And they essentially killed the first president of the United States by bloodletting him. What this guy comes around, and by the way, he discovered this long before Washington. This is 1578 to 1657. So he comes up with this theory, but no one really accepts it for a couple hundred years later because Washington died in the early 1800s. Or mid-1800s. But this guy comes up with a theory that is proven true, and Washington doctors would have done well to have studied his notes because he discovered that the heart alone acts as a pump that pushed blood through the arteries and veins. Blood didn't just sit around weightless until it went bad and then you had to bleed it out. Now, next in the field of medicine, you had Edward Jenner. And no, we're not talking about the former Olympian that became a woman. No, we're not talking about that Jenner. Edward Jenner, he is known for creating the first smallpox vaccination. Now, smallpox is a horrible disease. You can see the papules that you see right there on the picture of a victim's hands. Now, I want you to read on 365. I want you to read the explanation of what the smallpox virus vaccination does. Jenner speculated that if a person were inoculated with the fluid from a cowpox sore, he would then be immune to smallpox. He tested this theory by inoculating a boy with cowpox, from which the child later contracted only a mild case. Later, they inoculated the same boy with smallpox. The child did not contract the disease. And Jenner called this method of inoculation against disease vaccination. So we have him to thank whenever you go to the doctor's office to get a prick, to get more medicine put in. Okay. Now next in medicine, we've got Joseph Priestley. And this is actually, I think this is actually supposed to be under chemistry. Yeah, this is supposed to be under chemistry, but it really doesn't matter. Joseph Priestley invented laughing gas. When you go to get your wisdom teeth taken out, you have him to thank that you don't have to feel all the horrible pain you're about to feel because you're just going to be laughing all your way to the bank. All right. And then next you have Antoine Laurent Lavoisier. He is known as the father of modern medicine. That is not supposed to say medicine. That's supposed to say chemistry. So he's known as the father of modern chemistry. Then you've got Anton van Leeuwenhoek. And he updated the microscope so that it would magnify to 160 times. That is an incredible discovery that has benefited doctors the world over. And then finally, the last one, Gerhardus Mercator, he developed a way to map the Earth on a flat surface. So these are all the notes you need. I am skipping to the end real quick. Go ahead and take these notes down. I want to remind you that you need to be keeping up with your homework. Today, this is for the this should be for the 24th, so you shouldn't have any homework for this day. But you need to remember that you have the SRQ from Monday. You have an open book test you have to do. And you need to get ready because on Wednesday you're going to have work. So you're going to have to get ready for that. All right, go ahead and get to work on that. I just want y'all to know that I love you and I'm praying for you always.